The primary goal of our project is to enable an intelligent tutoring system to monitor the cognitive load of a student without relying on expensive hardware to do so. To understand what that means, let's start by thinking about the current state of the educational system. Consider the following description from CGP Gray's video called Digital Aristotle: Thoughts on the Future of Education.
This is how schools have pretty much always looked. A guy in the front who knows all the things and students who don't, so the guy tells them. But a teacher explains things at the right pace for maybe one student in the room during a lesson. Everyone else is either bored because they already understand the material or lost because they're missing knowledge they should already have. But at the end of the lesson, regardless of student understanding, the curriculum marches relentlessly on.
This problem isn't hypothetical. Educational psychologist Benjamin Bloom reported in 1984 that the average tutored student performed 2 standard deviations better than conventional students. So, if you take 100 students and tutor them, and 100 students and traditionally educate them, 50 of the tutored students would perform as well as the top 2 best students from the traditionally educated group. Imagine a society that creates 50 high-performing members for every 2 high-performing members that another society creates.
In a perfect school, each student would have a personal tutor, like Aristotle to Alexander the Great. But if your education policy is Aristotle for everyone, then there are 3 big problems with this. First, there aren't enough humans on Earth to individually tutor every child, and even if there were, it would be horrifically expensive. And even if neither manpower nor money was a problem, not everyone is as good a tutor as Aristotle. What I see coming is this: Digital Aristotle for everyone. A computer program that tutors students individually.
In the world of educational technology, what CGP Gray refers to as a digital Aristotle is called an intelligent tutoring system. Now, because we only had a short summer semester to build our project, we couldn't build an entire intelligent tutoring system. We focused on building just one component, so we created a way for the intelligent tutoring system to know how hard a student is thinking in real time. To accomplish this, we combine techniques from computer vision as well as psychology. Our approach relies on tracking the pupils, which dilate when someone is thinking. By calculating the percent change in pupil dilation, an intelligent tutoring system would know if the student is thinking about the material or if the student is lost or bored. To get started, we need to identify the baseline pupil dilation. To do that, we run our system and track the pupil without providing any sort of cognitive load to the subject. Once we establish the diameter of the pupil under the current static lighting conditions and without any cognitive load, we can then use this as the baseline parameter and start tracking the percent change of the pupil once the subject is engaged in thinking. In this sample video, the subject is being asked to do simple math problems, and you can see the PCPD in the top left corner of the window being rendered in real time. It fluctuates quite a bit, but you can see that it's positive and hovers between 5 and 20% most of the time. So to interpret this data as if you were an intelligent tutoring system, what you can do is think about the fact that increased cognitive activity corresponds with increased pupil size. So when the percent change in pupil dilation is positive, that means the student is thinking. And the higher that the PCPD number goes, the harder the student is thinking. If it is 0 or negative, that means they are thinking less and they're not paying attention. Now that we've seen the system work, I want to discuss how somebody might incorporate this into an intelligent tutoring system. What we've created is a locally running web service that can be accessed from the local computer via the HTTP protocol. Because different computers will have different web cameras connected to them, there's a configuration that can be sent along with the HTTP request. And this can be used to fine-tune the way that the algorithm detects the pupil and handles the varying lighting conditions. So for a little bit more detail about the configuration, it's a JSON object that is URL encoded and put into the URL parameters of the HTTP GET request. So the developers of an intelligent tutoring system that use our component would build a way to calibrate the system to the camera and lighting conditions of the learning environment, and then they can post that configuration for analysis to our component through the web service. And here I have another sample video with different lighting conditions and different resolution. And here you can see, although everything is different about that video, it was still able to track the pupils correctly because of the calibration parameters. So that's our project for the Georgia Tech CS6460 Summer 2017 Semester Educational Technology course. This was the Biometric ITS team consisting of Bogdan and Greg.